Yeah, welcome back to my YouTube channel. Thank you for joining me. Still talk about gradients and specifically gradient of straight lines. How do we discover, how do we solve, how do we come about the solution of the gradient on the straight line? Now, quickly, let's assume we have, of course, this is the coordinate, this is the straight line, we have this coordinate x, we have y, right? Now, having this, we have 2 points here. So I call this point P, I call this point Q. Then point P, we have coordinates x1. Let me write that at the top. We have x1, y1, right? This one too, we have the coordinates x2, y2, right? Now, good. We have to calculate the gradient of this line. Now, what is gradient? Gradient actually means the change in y with respect or ratio change in x. Because there's going to be a change here. Calculating this slope, this is slope actually. So how do you get the gradient of this straight line? How do we do it? So what we will do is this. Let's relate it to a triangle so that we can get that out. What do we do here? Let me draw an imaginary line here along this path. Then I have along this path, I call this place R. Then I know exactly that if I draw this out, if I extend to this place, this one will be my y1, because this is my y axis, right? If I extend this place to this to the vertical axis, I have this to be y2, right? So if I extend this down, I have this to be x1. If I extend this down, I have this to be x2. What does that imply? The distance between P and Q should be x2 minus x1. Equally, the distance between R and Q should be y2 minus y1, right? Good. So with this, you can get the gradient of our straight line. And what do we do then? You can say the gradient of this PQ. Gradient which we denote by m, we denote gradient by m, notice that it is equal to change in y divided by change in x. So what does that mean? That implies also that the gradient is to be equal to, what do we have? That's what our change in y, that's y2 minus y1 divided by x2 minus x1. Right? Good. Now, this gradient, I haven't gotten this. There is another thing, there's an angle that is formed between the slope and the what? Horizontal positive axis. So what is that? This angle, we call it alpha. Now, the relationship between alpha and our gradient, observe very well. From here, you observe that this is a right angle triangle, right? The right angle triangle. So this is opposite, this is what? Adjacent. So what do we have? That implies that tan alpha is also equal to change in y over change in x. And our change in y is opposite over x, and this is equal to this. So what does that imply? That implies that tan alpha is equal to our gradient. So that means whenever you have the angle, what we call the slope angle, is alpha. The tangent of that angle, or the value of that angle, is equivalent or is equal to the gradient of the line that produced that slope angle. Okay? Good. So let's quickly solve a question here. Look at this question. We have calculated the gradient of a line with point A, 3, 2, B, 7, 10, and the slope angle. We are looking for two things. So let us solve. By solving, what do we have? Our gradient is always equal to what? So here we can turn these ones. What we have there, we call this one to be x1, this one to be y1, this one to be x2, this one to be y2, right? So we can impute our values now. So what do we have? y2 minus y1 upon x2 minus x1. That is equals to what our y2. y2 is 10 minus y1 is 2 divided by was our x2? X2 is 7 minus x1 is 3, right? Good. Since this is going to be adding, we are going to be adding 8 divided by 4, and that is equal to 2, right? That means our gradient is 2. This is gradient. Now go to the next question. The next question says that what? What is the next question states? The next question states that we calculate the slope angle, and our slope angle, what is it? Is this? That we're looking for it, right? And when we know that there's a relationship between the slope, the tangent of the slope angle, and our gradient. So we write that we call tan alpha is equals to this, right? So we can say tan alpha is equals to 2. Then our alpha can now be equal to the tan inverse of 2. So alpha should be equal to tan inverse of 2. Tan inverse of 2, checking my calculator, let's be straightforward. That is 63.43 degrees. 63.43 degrees. We have done the 2 questions. Join me in the next video talking about different forms of gradients. Forms in their different in their forms. Gradients in their forms. So I go from there, we'll calculate more. Thank you for joining me, and God bless you.